Good afternoon. Today we'll be talking about data structures, and my name is Saksham Dixit. So, to start off, let's talk about algorithms. What is an algorithm? An algorithm is a way of solving a well specified computational problem. Furthermore, it is a finite set of rules that give a sequence of operations for solving a specific type of problem. So, let's look at the example of making a sandwich. You have two breads, then you spread butter on them, then you would cut cheese and then tomatoes. Then you put the cheese and then the tomatoes on one bread. Then you put the other bread on top. And now it's ready to eat. This is an example of an algorithm because if you follow this process every time, you will get the same result. Now let's talk more specific algorithm. Euclid's algorithm. So Euclid's algorithm is used to find the greatest common denominator of two positive integers. Now let's consider two positive integers m and n, such that m is greater than n. The first step would be to divide m by n, and the remainder is r. The second step would be that the algorithm ends if r is greater than 0, and n is the greatest common denominator. The third step is if r is not equal to 0, then you would set m equal to n and n equal to r. Then you would repeat the process. This is a recursive algorithm because the algorithm is being repeated until a certain condition is met. And we'll talk about recursion more later on. So here's the Euclid's algorithm code. You could always look at this on your free time as it will be updated to the Udemy course. Now let's talk about bubble sort algorithm. Bubble sort is a sorting algorithm that starts from the first element of the array and compares it with the second element. If the first element is greater than the second, we swap them. It continues this process until the end of the array, and then the largest element bubbles onto the top. You will get the worst sorting performance when the data is from biggest to smallest. And here's a GIF on the right that displays bubble sort happening in real time. As you can see, the 8 and 7 were swapped because 8 is greater than 7. So why algorithms? Algorithms help with giving estimated runtime. They help decide on hardware requirements. They help you conclude what is feasible versus what is impossible. And finally, improvement is a never-ending process. We always strive for the most efficient and quickest algorithm. Now let's talk about why data structures. Firstly, let's establish what a data structure is. A data structure is a way to organize, process, retrieve, and store data in a specific format. Typically, you want to choose a structure that will make it easier to find and sort an item in your program. Now let's look at these two images below. As you can see, the image on the left, everything is more organized, meaning that it'd be much easier to find a certain element that you're looking for. The image on the right, however, is completely unorganized and there is no sort of sorting whatsoever. This will make it really difficult to find the element you are looking for, and you'll most likely just have to go through all the books there, which is never the most efficient solution. Now let's look at the correctness of an algorithm. It has to meet these three criteria for it to be considered an algorithm. Firstly, there has to be a statement to be proven. The second step would be that you have to list all of the assumptions. And the third step is that you would use chain of reasoning from the assumptions to the statement. Now let's look at the incorrectness of an algorithm. First, you would try to give a data set for which the algorithm does not work. You typically want to consider small data sets, and especially consider borderline cases because those are the ones that your algorithm often is not accounted for. And that's it for this video.